Hi, everybody. We're going to do Q12, which is completing a function table from a graph. So we're going to see a picture, and then we're going to fill in the points that are the solutions to that graph. So let's take a look at it. This is Q12. Complete a function table. Yeah. Okay. Use the graph of the function to complete the table. So we are supposed to choose given the input and the output that they gave us. We can see already that 7 goes to 1, and that is actually called the vertex on here. We can see they gave us that one. That one's right there. That's the vertex. And they gave us the 9, 3, which is right there. And they ask us what value on this graph is represented by the 3, which is right there. So you have to go up to where it's at. It looks like it's at 9. It's right there at 9. So we're going to put in the 9. Let's see what else they got for us. Oh, a nice linear function. And we have a 1, 1. It's right there. We have a 5, 7, which is right there. And we want to find what goes with 7. So 7 goes to 10, doesn't it? Okay, this one's a negative slope. It goes through the y-intercept at 0, 7. It has the point 0.63, and we want to find the point 0.91. There it is. Oh, a parabola, a downward parabola. Let's see. 6, 6 is not going to be the vertex. 5, 6 is also not the vertex. It's in between those two. Chances are really, really good that it's the exact midpoint of those, which looks like it's at 5.5, isn't it? Anyway, looks like it's going to be at 6, 6. Oh, sorry, you can't see me. There, how's that? All right, we've got 1, 0, which is this x-intercept right there. And then we've got 2, and 2, negative 3 is going to be our vertex. So we're going to need to fill in that one. So we're talking about 2, negative 3. It's called the vertex. And then we have another one at 3, 0, don't we? We have another point at 3, 0. So we need to fill in both. We need to fill in the negative 3 and the 0. Let's get in there. There we go. Okay, this one is probably a 4th degree polynomial. And this means that it's going to be something that looks like y equals ax to the 4th plus bx to the 3rd plus cx squared plus dx plus e. Big, long polynomial. And the way I can tell is because you see the ends are both going in the same direction. That means that my biggest power is an even. And because it has curves in it where it crosses one of the lines 4 times. See that? 1, 2, 3, 4. It means that if we had translated it the right way, it would have crossed the x-axis in 4 places, which would have given us 4 zeros. That's how I know it's a 4th degree polynomial. Lots of more stuff than you wanted, though. So let's get back to the question at hand. So at negative 5, let's see where we are. Let me go ahead and put those in. So we're at negative 5, 2. There's one of our points. And we're at 2, 2. There's another point. And the negative 1, 2 is located right there. Notice there's some symmetry, well, sort of symmetry going on. This point right, wait a minute. Oh, the negative 1, 2. The negative 1, 2 has a name. The negative 1, 2 is called the point of inflection. It's where the curvature changes from being curved up to being curved down. Anyway, a little extra stuff there for you. So it looks like we're going to negative 5, 2, and we're also going to 2, 2. And notice that we have 3 solutions on this line. Oh no, 4. I missed one. There it is. There's the other one. Okay, so anyway, there it is. More than you wanted, I know. Okay, so this one is a cubic. The point of inflection is probably right there, I believe. So let's take a look and see what we've got. We've got a negative 1, 2, which is the point of inflection. And then we've got a 0, negative 1, where it crosses the y-axis. That's called the y-intercept. This one is, again, a 4th degree polynomial because it has 4 zeros. We've got a 5, negative 2. Wait a minute, where's 5, negative 2? Oh, there it is. Yeah, I think that's the point of inflection, all right. 5, negative 2. We've got a 9, negative 2. There's another one. So 9, negative 2. And we have a 10, negative 2. And notice I also have a 2, negative 2, which is my 4th of those sort of zeros. They're not what we call zeros. The zeros occur on this x-axis. It's where the polynomial is equal to 0. It tells us a lot of information about it, and it's an important points. But we'll go ahead and put them in. Negative 2 and negative 2. And notice it is still a function, even though we're getting the same output each time. It's fine. Okay, this one looks like a inverse graph, a y over 1, y equals 1 over x, something like that. Could also be a negative exponential. You know what? It could be a negative exponential. So it could be a, let's see if I can tell. Oh, I know you're not very interested. Yeah, could be. Nah, I can't tell by looking at it very well. Anyway, 3, 4 is right there, and 4, 3 is right there, and 6, negative 3 is right there. Be careful. I almost went with the negative 2, but we can see it's a little off. That's going to be at 6, negative 3. So we're at 4, 3 and 6, negative 3. We're just reading the graph, that's all. Looks almost like a stock market ticker, doesn't it? All right, so we've got negative 8, negative 4. And we need a negative 2 just down here. Excuse me, at negative 7. Looks good. Let's take a look here. Oh, this one's a combination type of graph. It looks like it's an absolute value mixed in with a parabola. We change at the negative 4, don't we? See that negative 4 is where my change is. Let's see, what are we looking for? We want negative 4, which I suspected was one of the points they wanted. And the negative 4 is right here at negative 5. And 10 is at, looks like negative 9 maybe. Lots of combinations going on here. We've got negative 10, 1. Be careful, it looks like it's going to 0 over there, but it's actually at 1. At negative 10, it's right there if you need to see it. -9, it's already at 3. Just a little bit 2 in between there. Looks like that's it. Now this one is called a jump discontinuity. This is a non-continuous function here. It is a function though, because a lot of people are going, well, wait a minute, aren't there 2 points on this line right here where x is equal to -6? Sorry, I got a little wavy there. But see that there's an open circle here and there's a closed circle here. So it means that this is the one that counts, the -6, -6. The -6, -3 doesn't actually appear there. That's why it has an open circle there. So the -6, -6 was our point right down there. We've got one at 10, looks like 2, 10, 2, right there. And -7 is right there at -4. Okay, we've got 2 discontinuities here. Let's see. At 0, we're at the -3 this time. And at 6, we're actually at the -4. That's the one that counts. Just want to make sure that you are able to read that, I guess. And this one, I'm going to do it again. We've got one at 4, which is at -4, right there. And we have another point, come on, 7, looks like it's going to -7. It's this one right there. That's filled in. Looks like we're getting there. Just keep at it. Okay. Looks like at -10, we're at 7, right there. At 4, we're at 0, aren't we? And at 10, we're at -4. Just filling them in. Okay, got a bunch of things going on here. -10, we're at this horizontal line at y equals 9. That's actually part of the graph. So -10, we're at y equal to 9, which is called g of x in this case. And then at -4, we're at 0, right there. And then at 10, we're all the way down here at -9. Looks good. Okay, this one, pretty wavy looking line. Looks like one I drew. Okay, we've got -10, which is at 7, right there. So we've got a 7. I'm just going to write it next to it. -9, we're at, looks like 6. Because it's this one, not that one. At 10, we're at 2. I don't think there's any others. So, yeah, that's it. So 7, 6, and 2. Okay, looks like we've got -10 is at -3. -1 is at 2. And 10 is up at 6, right there. We have one last one. So I hope you guys will try it yourself. A couple of jump discontinuities here. That's what we call these things. And remember that it's the point that's filled in that matters. At -10, we're at 1. At 9, we're at 0. That's the one that counts. And at 10, we are at 2. And I think that's all of them. Yep. 1, 0, and 2. All right, guys, I hope you guys will try it yourself and go to your 100, get them all done, read those points, and have a nice day. Bye.